Okay, so it says homework quiz, but it's really our bell ringer. Ooh. It says homework quiz, but it's a bell ringer, and I wrote it terribly, so I'll rewrite it. Okay, so our first one, we see that they're both already in the same unit, right? So they both already are in inches, which means that we can cancel the inches out. But now we have to look for something that's in common between the numerator and the denominator. So we see 7's in common with both of them. So how many times does 7 go into 14?
2.
How many times does 7 go into 42? 6. So now I'm at 2 over 6. Can I bring that down any further? Coda?
Couldn't we have just used 14?
We could have just used 14. A lot of people aren't familiar with the factors of 14. So you could have used 14, and then you had 1 and 3 immediately. But here we see that 2 goes into 2 how many times? 2 goes into 3 how many times? So our answer is 1/3. The only issue with the next one is you have to remember to change the units. This is in yards and this is in feet. So how many feet are in a yard?
3.
We have 3 feet in a yard. So we're going to have to change that. Yes, it did. And we see we have 3 feet over 1 yard. When we do this conversion, the yards cancel. We end up with 6 times 3, which is 18 feet, all over 10 feet. We see they have the same unit, which means we can now cancel those. And then we can reduce. What goes into both 18 and 10? 2s. How many times does 2 go into 18? How many times does 2 go into 5? Or 10? I can't help myself.
Can I write on the iPad since I don't have any?
We are on our next one. So in the next one, we have the diagram. And we see that FG to GH is 1 to 3. And we know that the total length of the segment is going to be 12. And then they want us to find the lengths of the 2 smaller parts of our segment. So when we did this last week, we looked at it and we saw that we didn't know what the amount was. And so we represented it with an X. So here we have 1 part and we had 3 parts. So every 1 part of this, we're going to have 3 parts of this. So now we have to solve for it. So we're going to create that segment addition statement. So here we see we have 1x plus 3x equals my total length. What's my total length of my segment? 12. Combine like terms, I get 4x equals 12. Divide by 4 to isolate that x. X equals?
Ms. Jenkins, can you please slow down?
Yeah.
YouTube today.
We're back. And so we see we have the measure of x equals 3. But were we looking for that? No, we're looking for the lengths of FG and GH. So I don't have a lot of space in mind. So I'm going to go work right back up underneath those 2. I see that FG equals 1x. And we know my value of 1x is just going to be 1 times 3 is 3. My second part is going to be GH. GH equals 3x, which is going to be 3 times 3, which is equals 9. So our 2 lengths are going to be 3 and 9. For question number 4, we're back to perimeter. We did a problem like this, and our first step in a problem like this is writing out or drawing your rectangle. I'm on number 3 right now. So we're here, and we're going to draw that rectangle. Now that we've drawn our rectangle, is perimeter, if you're looking at this room, is perimeter the length of the walls or the amount of flooring on our ground?
Length of the wall.
It's the length of the walls, right? It's the fence that holds stuff in. Area is what is on the bottom. So now we are dealing with that. We know that we have length, width. So our perimeter, are you guys doing okay over here?
Yeah.
Okay, so our perimeter equation equals 2 length plus 2 width. How much is my perimeter? What is our perimeter length? 84. And then now we have to use that ratio. We see for every 2 parts of width, we have 5 parts of length. So now I have to create those. What length and width are equal to? Well, we see that width is equal to 2x. Notice again that the coefficients match the ratio. So 2. Over here we have length. Length is going to be 5x. And so those match. Say it again. Okay, I thought you asked a question. Okay, so now we're going to substitute in what we know. We have 2 times 5x plus 2 times 2x. Okay. We are at this point, and you are now going to distribute your 2's. Did you have a question? So we have 84 equals 10x plus 4x. We have 84. I am out of space. I'm going to write it over to the side so that you guys can see it. So it's going to go right over here. We have 84 equals 14x. So Serenity, I think you already said it. How many times does 14 go into 84? So we have x equals 6. But again, that's not what it's looking for. It wants length and width. So now we're just going to substitute it back in. We see that width equals 2x. So it has to be 12. And we see that length is 5x, which Rio's already solved, and we see that that is 30.
Where's 12 come from?
So 2 times 6 is 12, and 5 times 6 is 30. Here for number 4, that again, we're doing that cross multiplication. So we see that 1 times 22 is 22. And we have 2 times x, which is just going to be 2x. Solving for x, we're going to divide by 2. X equals 11. Yep, nice job. So we have to identify similar polygons. So our objective is to be able to identify similar polygons. So this goes in your objective portion, and we're studying 7.2, which is titled Similar Polygons. So similar polygons are figures that are the same size or same shape, but not necessarily the same size. And then we see that corresponding angles are congruent, and that corresponding sides are proportional, which is what we saw in our Three Stooges activity. Now I'm going to label these 2, and I ask that you label them as well, so we can do the next part of this. We have A, B, C, and D. Over here we have E, F, G, and H. So our first part is, I'm going to put it up here, is we're going to identify the corresponding angle. So at the end of last semester, we learned about corresponding angles and corresponding parts. So we see that angle A is congruent to which other angle? So A is going to be congruent to angle E. We see that angle B is congruent to which one? F. Angle F. We have angle C, which is congruent to angle G. And we have angle D, which is congruent to angle H. Thank you. Okay, so we're going to come up with those ratios. So on my numerator, if I had it as EF, which side would be the same than the other one? So we have EF here. So on the other side would be AB. Then we have, let's see, FG. And what is that over? FG, and we see that that's right, class. Way to go. BC. Whew. Okay. And then we have CD.
Can we write this in a different spot, or does it have to be under?
You can write it wherever you have space. I don't have the space, so I put it there.
I don't have a space right
Yeah, I just didn't have it, so I put it where I had it. So we have CD here. And then the corresponding side with that would be GH. Ooh, I flipped it. Sorry about that. Okay, so I flipped it. So again, I apologize. So that'd be EH or HE. And it's going to be DA. And then we have, which one did I forget?
CD.
CD? Okay, thank you. So we have CD, and the numerator is GH. Okay. So we see that we have scale factor. I am bothered by this is the way it's written. The word scale factor should be also at the last part of this, but you don't want to use the definition inside of it, right? The word inside of it. So I read it as if similar, the ratios of the side lengths are called the scale factor. Instead of this, that's what I put there. Our next part is I'm going to ask you to label these triangles just like I'm labeling the triangles. Yeah, it's a Q, sorry. So if we start with angle R is congruent to which other angle? Yep, it's congruent to angle T. And we have angle P, which is congruent to angle S. And we have angle, which one am I missing? Q, which is congruent to? So with this, the angles are congruent and the sides are proportional. So if you remember the way we wrote these when we were talking about triangles last time, we saw that P and S were congruent just by the way we wrote these. That still holds true here. Okay, so our next part is to create those ratios. So we have our ratios for this portion. And if I put ST down first, ST is over which part? PR. Which is next to TU. TU is over RQ. And then we have US, which is over QP. Our last step is to actually perform these ratios since we have the numbers. So we have ST. I'm going to put it here. ST is what value? 8 over, what's PR? It's 20. Okay, we can reduce that. 4 goes into 8. How many times?
Is that an R, PR?
Yep. I can't. There we go.
That's that lazy ratio.
It's because my eraser was giant. I had to redo it. Okay. 4 goes into 20. How many times? 5. We're on to the next one. We have TU and RQ. TU is what?
16.
Over?
4.
40. 8 goes into both of these. How many times does 8 go into 16? How many times does it go into 40?
5.
Okay, and our last one is going to be that US over QP. US is 12 over QP, which is?
30.
Okay, 6 goes into both of these. How many times does 6 go into 12?
2.
How many times does 6 go into 30?
5.
So we see that they are proportional because all of these ratios are holding. Let's begin by naming those angles. So we have angle J, which is congruent to angle Then I just did them off to the side, so I apologize for that. I didn't love them sooner. Okay, and then we have angle M, which is congruent to angle R. We have angle K, which is congruent to angle, I think I heard it, P. And then we have angle L, which is congruent to angle Q. Our next is to do the ratios. So if I put, let's see, I did mine with JK beginning. So if I did JK, no. We have P, or NP. I have JM, which is over NR. I have ML, which is over RQ. And I have LK, which is over QP. Now that I have those, we then have to define those ratios. So we're going to plug in the numbers that we know. So I'm going to do that over to the side. We see that we have JK over NP. What's the measurement of JK?
Just kidding.
Yep, 2 over NP, which is? Can I reduce that any further? No, we're good. JM over NR. Yeah, 2.8 over 4.2. Okay, sorry. Can we reduce those? We can. If this is not something you like, there is a way to do this on your calculator. So I'm going to look over real quick. Actually, I don't have to. So did we talk about this yet today? You're going to put this in your calculator. 2.8 divided by 4.2. Then you're going to hit your second button. So that blue second button. And then you're going to hit PRB, the probability button. PRB. And that's the fraction to decimal, decimal to fraction button. You hit enter. And we see that it reduces it for us. We have, 2/3. We have our next group over here. We have ML. I'm going to change color so they don't run together. Okay, so we have ML over RQ. ML is what? 4. RQ is 6. That reduces to 2/3. And then our last one, which I'm going to write over here, we have LK over QP. LK is what value?
Okay. That's 2.
And QP is? Okay.